Performance Expo viewers, Lake Speed Jr., here my buddy John Callies, and man, we've been having some fun today talking about all kinds of stuff. We'll take you guys upstairs a little bit and show you some of the footage and things that he's got on his wall of fame, and we don't call them parts of shame, but they're all wall of fame stuff up there, pretty cool. But John, we've been talking just today about all these iterations of valve train technology. You've been around this for a long time and really pioneered a lot of things. And one of the big changes that's come along, basically in the NASCAR community, is that we went from always having to run flat tappet cams to now we run roller cams in the last 5, 6, 7 years. And over time, flat tappets have begun to kind of phase out, and roller cams are becoming the dominant form of camshaft valve train in the market. But there's differences between roller lifters of OEM level and then what you run in, say, a cup engine. Just like at the very end, the chilled iron lifter you could buy for a flat tappet to rebuild your small block Chevy wasn't anything remotely like the tool steel DLC coated flat tappet lifters we ran in NASCAR. Materially, they were different. They're still a solid lifter, but they were very different in terms of material, coating, and design. So if you would, kind of help us understand what we're doing with the hydraulic lifters today. And really, obviously, it's a big deal, right, with the street performance crowd. You've got these people that want 1,000 horsepower on the street, but they don't want to have to go to change valve lash. So talk about how we address those problems.
I think a couple of things. We made flat tappet lifters. Okay, but we have such a backload of roller lifters currently.
Right.
We probably will never make a flat tappet lifter again.
Got it. Because the market demand is roller cam.
Roller cams. Now, the flat tappet that the cup guys used were very expensive components.
Yes.
So
I have a couple of them at home on my desk still. They were really cool.
And the point is, a set of lifters, flat tappet, that costs $2,000.
Yes, exactly.
That really is not for the average guy.
Right.
Okay, go to a roller. So what we're seeing is the first roller lifters were in 1986 in full production.
Okay.
And yet track owners and people running flat tappets felt that it was an inexpensive way to go. And they would get a certain amount of life out of them and then just replace them.
Right.
That's way different than what the cup guys do. In other words,
Right.
a cup flat tappet roller probably, before you put a grind on it, it probably is $1,400.
Right.
Now you got to have a grind put on it and all the other things you do, and now you got a $2,000 camshaft.
Right.
So, although we provide lifters to that market, our big stuff is what's happening with people, shaft off cells,
Right.
people like that, and they need a good lifter, not a high end. They want a good race lifter that gets the durability.
So what makes it a race lifter versus a street lifter?
Okay, a street lifter will have a tolerance on diameter that can vary 3 thousandths. Okay, our race stuff, we want to have a lifter that the diameter is holding 0.5 thousandths.
Okay. So from 3 thousandths to half a thou. That's your tolerance.
And then we go to the cup stuff, and that's 3/10.
Oh, yeah, great. Yeah, that's great.
So the point is, though, when you get a set of lifters, they should be within 3 or 4 tenths up and down the lifters that you're running. Now, we use all carbon gauging at the final QC lifter through to try and keep this stuff in that area. And so, your grind time goes up versus when you have a large tolerance.
Sure.
And then when you want to add DLC cooling, that's an additional cost. Now, when we go from a standard 700, this is a 750,
Okay.
but our hydraulics are a 700.
Okay, 700. Okay.
Okay, well that,
The 700 means the wheel diameter.
and that package, we have upgraded when we started, and it's a great overall performance package. But what we have is people want to run a hydraulic and say, I got 1,000 horsepower. And I'm saying, well, that's wonderful. But I personally think everybody makes a short lift cam shaft, all the cam, right? And when I say that, you're running anywhere 6,000 or 7,000
Sure.
clearance. I would put a solid in. The only thing the hydraulics do is if you have a turbo package and hoses and crap everywhere to get the valve. But like the 40, I adjust it maybe twice a year, and I'm not really changing it much.
Got it. So you're saying for the big horsepower guys on the street, if they can, it's probably better to actually run a solid roller lifter.
Yeah, and the thing, it got into a game out there. I've got 1,000 horsepower and I got a hydraulic. Well, the one thing you have to realize, even on our best hydraulics, it's the bleed down rate that we change.
Exactly.
Okay, so we're getting tighter tolerances, and it becomes less forgiving because you're going to a higher RPM. And I'm saying, why say that I have a hydraulic? Because you're going to give up some horsepower.
Right. Yeah, exactly. The lifter will become unstable at higher RPM
Yeah,
because of the hydraulic nature of it.
Exactly.
You're going to get more air in the oil, which means the lifter becomes spongy, which means it doesn't act solid anymore at some point, and that's where you begin to.
And so I say, if you can get to the valve covers and you use a short lift camshaft, run the solid. You know, I mean, to say how impressed you are, you're giving up power down the road.
Right.
You know, and so it becomes a talking point that I never have to adjust the valve. Believe me, you're running up some horsepower.
Got it.
Yeah.
So for the people that don't, I look this way. We know that when it comes to flat tap and stuff, people do, okay, you had hydraulics for your street stuff, you had solids for your race stuff, and hydraulics for the street. And then you get into roller lifters, and pretty much I think everyone kind of just said, okay, well, there's roller lifters and there's hydraulics and there's solids, but there's a whole lot more to roller lifters than just solids and hydraulics. I mean, just looking at the layout you have here, talk a little bit about the different designs. You mentioned DLC earlier.
Right.
So, and then we've got needle bearings and bushings. You've got dog bone. You've got keyway. Explain the differences and why they exist.
Well, the one thing is we offer the DLC coating on pretty much all our lifters except the low end.
Right.
It's an option.
Okay.
But what we've done,
Explain what DLC is for people who may not know what DLC is.
it's diamond-like coating.
Okay.
And it's very, very thin, but it's very hard. The one thing you have to do is the lifter finish has to be acceptable
Yes.
to accept the DLC coating.
Right.
So again, that becomes a process point. So
Exactly.
we make what we call a light, which doesn't have the coating.
Okay.
Okay, and we make that with the Black Mamba.
Sure.
Black Mamba Light versus the DLC.
Yep.
And what we see is people don't necessarily finish the doors right,
Correct.
and that cuts down on the durability and life of the product. Now, when we get the cup stuff back for rebuild, honestly, it looks like it never was run.
Exactly.
I mean, we're just blown away.
Right.
But now you have everything correct.
Yeah. On
And-
surface
and-
prep and
Now we have aftermarket engine builders that do a very nice job, but they have a good, they're no longer hand honing doors and doing all that stuff.
right.
Now when you get to older stuff, let's say Butler Performance does pump.
Yes, sir.
Okay? and he has, I don't know how many old blocks. Well, he's now moving to doing bushings in the block to have the right clearance. And you have to think about this. When you do, let's say, a Pontiac or an old Buick, they all came with flat tappets.
Exactly, yes.
Okay, and they have a very short boss. It's lifted up. Now you want to put a roller cam in. If you don't do the proper things, you have issues. You put a bushing in, it solves a million items.
So you're saying is when the block was designed for a flat tappet, and it's a short cylinder essentially, it's not for the flat tap is a short lifter. The ratio works out for it to support it.
Well,
but it can't support something that much taller.
Well, the biggest thing is let's just take a Pontiac as an example.
Sure. Okay.
The base on a flat tappet is like 1'385". You do a roller cam and they want to stick in 1'180" diameter base. That creates 80 million problems. You know? So how do you solve it? It's with bushings. Okay, and then the customers go, I don't want to spend the money on that. Well, you know, how well do you want this thing to run if you go low?
Okay.
And to me, these engines that he does, the cars they go in, the cost of that car has gone up. So why not just do it?
Well, it's back where we said so many times before here in different segments of the Expo, it's soup, not steak. You have to think about it as a combination. You may not want to buy these because it costs money, but the reality is if you buy these, you have to have these.
Yep.
This will not work without this.
Right. Because
you can try it, but it's not going to live very long, and you're going to have a problem.
Well, you see, the other thing is I'll have an end consumer call and say, look, I've got a 730,000 lift camshaft, and I want to run a hydraulic. And I go, why? Come on, guys. You know, I mean, you're stretching. Well, I got it to run. Yeah, but believe me, it's not giving you the power that you need.
Well, it still goes back to the durability piece, the NASCAR experience. The small blocks in the old days, you were happy if 5, 6, 7 of them finished a race. Well, they all finish races now. If you blew up 5 or 6 in a year, it's a big deal. So it really isn't the fact that they make more power now than they used to. But it really is the durability. You can, so the qualifying motors, what I kind of think about, you can get away with a whole lot of stuff once or twice. But sooner or later, it catches up to you if you don't have the durability. And what you're really talking about is if you want it to be a durable package, you have to have all the right parts working together to create that durability. You can get away with a few things for a little while.
Well, and look, I mean, the Cup team owners saw the cost of all this special engines for qualifying. And they got with NASCAR and they said, we're not going to do that. And now you show up at the track and you run. And racing has been great. I mean, all it does is the teams that are winning put more emphasis on preparedness going there. And I mean, with all the stuff they have to do testing with, it's unbelievable what the power of it is and how fast they're running and how close they're running. I mean, it's
pretty amazing stuff.
And do drivers make a difference? Well, Kyle Larson's showing that he does.
Yes, sir.
and so, to me, what Kyle was talking is raise the whole level of drivers.
They're all going to have to get better.
Yes. And I mean, he's an amazing cat.
So, this bushing, this lifter, this is what we call a keyway. Explain to the viewers how a keyway is different than the traditional style lifters with tie bar.
Yeah, and see a keyway, let's talk a big block where you have an offset lifter. We call it, when you put this tie bar on for a big block, you have to be very careful, or this can turn into a washing machine.
Yes.
Okay, and then it's supposed to work against the camshaft properly to keep everything straight. And
Yeah, it can't be off center. Yeah,
so
it gotta be straight.
then you go to a keyway. Now it's absolutely correct when you're keeping the roller lifter absolutely matched to the camshaft.
And that's because there's a key on the
Right.
side of the lifter.
That goes
Then
in.
there's a slot
Right.
in the bushing, so it just stays in that slot. And of course, this being a nice bronze material, alloy, it's nice and soft, and it runs in there. You don't have to worry about any kind of
Well, and
sticking
again,
score and galling.
the thing is, you can get, doing the proper machining, this can work very well, but it does has limitations. And when I say that, the test, now this happens to be with Hendrix, you're running, when you go to testing a new part, they run it to 10.5. They're not running anywhere close to that by the rules today. It's 9,500. They haven't chastened their testing. Their testing still goes to 10.5. Yeah. And so, luckily, our relationship with Hendrix is extremely close, and we get wonderful feedback. Now with EFI, if somebody over revs, goes fast into a downshift, they don't come back and say, we don't know what happened. They go,
We know exactly what happened, when it happened.
Right, right. So electronics has really, I mean, when I started, well, what broke? I don't know. and it was very secretive because each team felt he had something specific that was making his engines work.
Exactly, yeah.
Well, now it's wide open. You know.
That's right, exactly.
And so that's been good for us because you're not chasing something that you really know.
Right.
Yeah.
So, talk about the difference between this bushing style and the needle bearing.
Well, now, the one thing is, the fellows are needle bearing. In fact, we had one the other day that ran 360 degrees boiling.
Pretty hot.
Oh my God. For the race. So they sent the parts in. Everything was perfect. But that's because of the development of the materials to allow that to happen.
So so for your street lifters, your OEM type lifters, they have needles.
Right.
What is the type of material that's used in the needles on those OEM type lifters?
Well, the material that we use for our street lifting is different
From the OEM.
from the OEM.
So the OEM would be what, like maybe powdered metal or something like that? Or?
Yeah, the thing is, we've gotten this little street lifter to take a while to look at.
Okay.
And it's pretty amazing. And again, we don't divulge what the development
Material. Okay, yeah. So,
material just because
sure, that's fine.
it's a very tight industry.
Right.
You know.
Yeah, exactly.
But all I can say is each level has a different
Material.
different axle, different roller, and it matches what the pricing is.
Yeah. And they can also handle more stress, more load, more cycle time.
Yeah.
So essentially what you're saying is with the needle bearings, when you have that OEM lifter, the OEM replacement lifter, there's going to be a type of material in surface finish,
Everything.
quality, your range of specification is going to be here, but as you climb up the ladder, materials are getting better, tolerances are getting tighter, and that's what allows it to handle more load, be more aggressive, and then you move from the hydraulics to the solids, and as the valve train gets more aggressive, but then you bring along this little bad boy. So talk about the bushing, why the bushing lifter exists versus if just having needle bearings.
Well, the one thing is, this was a big development item, and we tested it. We've actually, in Infinity, we ran this in 2 races.
Okay.
Because it wasn't out.
Right.
And it did great, but they have every team owner gets a vote on whether they want to allow the new park.
Right.
And we had one team that felt that we had sufficient coverage on the needle and didn't want to go to having to go to another expense. And we certainly understand.
Right.
Yeah. You got X amount in your room.
Sure. Right. Yeah. Exactly. Yeah.
And so anyway, that was really why NASCAR turned it down. Wasn't that it wasn't better. It was going to put additional costs.
Yeah. Exactly.
With the team.
Exactly. So the difference really between, say, a bushing style and a needle bearing, for those who don't maybe understand, is that the needle bearing, the load is actually riding on the needles.
Correct.
And it's not riding on all of them. It's only riding on 2 or 3, depending upon what that line of contact is.
Correct.
So you have a very few number of needles, very small contact points. So the stress level is actually very high because all that load is concentrated on very small line of contacts.
And you see where you see it, these guys say, well, I got 1,200 pounds open. And I go,
those poor needles, they're dying.
And I go, why? That's because everybody else runs. Not that you rip. And what people don't really understand is, you have a 1,200 pound open spring. The amount of friction you're creating and horsepower you're taking away. And as I always say, if the valve train, that's the only way it can live, okay, but have you ever thought about going down and finding out where the gains are? Right. And usually people don't. Right. Like that's, because it's cost to do development.
Yeah, so you need spintrons to do that kind of work.
Yeah, so if this works for me, and Billy's using it over here, it works for me, you never get into where it can be from.
Right. And with this piece, as opposed to that load being carried by the needle, it's actually carried by the oil film.
Well, that's right. Right. Which is huge.
Right. So as opposed to it being, say, a mixed film lubrication condition, now you've got a full film hydrodynamic condition. So now oil choice becomes really important because you got to have flow,
right?
But you got to have enough viscosity to support it.
Correct.
So
it's like you say, it's never one thing makes me win.
No,
it's a system.
Yep, system.
And that's where we always get people say, well, my buddy works at ECR, and he told me if I do this, I go, you never can do that. Those guys are systems oriented.
Yeah.
And tested oriented. And hours to develop their system.
Right.
They're excellent.
They're chefs.
Yep.
They're making soup.
Yep.
That's just my analogy, right? You can hear me talk. You're gonna hear me talk about soup because like I said, systems, soup. It's just 2 words for the same thing. It's synergy. It's how things work together, not the components in and of themselves.
I was at one of the teams one time, and I said, "Why haven't you used the radius rocker that they're using on LS and LT engines?" We walked over to the cabinet, opened it, and must have had 500 different shapes. And that's why they go back to a roller bearing.
Right.
You can't make it work with the lifts. The other thing is, they want weight of the valve.
Oh, yes.
So they want the diameter of that stem to be as small as possible. And what they found is they were pushing it back and forth.
Okay. Oh, okay. Yeah. Got it.
And then having the teeth.
Got it. Yeah. Yeah.
So anyway, what sounds good, what is neat, but if I want the lightest valve, because that gives me RPM, that didn't work.
Okay. Interesting.
Yeah.
So, where would you say a bushing style lifter is applicable? Is it better everywhere, or is it something that only should be at those super high spring pressures? Because
to me, what it does is it gives you coverage at idle. So,
okay.
So going and using this versus a needle, it's wonderful because you have a higher carrying without damage with the film.
Got it. Okay.
So these guys that I want to have the biggest, baddest engine go to the drive-in, That's pretty
this is
nice.
better.
Yeah.
Okay, so interesting thought concept. I think a lot of people would probably say, oh, well, I don't have a race engine that's running endurance races. I don't need this level of technology. I'll just grab that. And really, for the guys with the 1,000 horsepower street motors and do this, this is really what they need is this piece.
That's correct.
Okay, cool. John, I always thought something every time I hang out with you.
Well, that's a lot of fun.
Well, thank you. Hope y'all enjoyed this segment. Thanks for watching.
Thank you.
And from Memorex to Live, we are joined by Mr. John Callies and, of course, Lake Speed Jr. So much information right there coming out of the video, but now we're gonna recap and double down. But the elephant in the room is the awesome car sitting right behind Mr. John Callies. Another one of your machines, the hit of the first Engine Performance Expo. One of the machines you brought in, and you've wowed us once again. Tell us a little bit about it.
This is a 40 Chevy, and it has a 557 cubic inch Pontiac in it.
Imagine that.
It's IR injected, dry sumped. Made a little over 1,000 horsepower to the rear wheels. We run it in the mile, and it's a street rod, so I've got 19,000 street miles on it, and fastest we've been is a 198.5 with it.
Just 198.5.
Yeah. So it's kind of a fun street rod.
What? 198 miles per hour in that thing?
Yeah.
Doesn't aero? I thought that's important.
I went to the wind tunnel with it.
Okay.
And surprisingly, you see the mirrors here? When
Yes.
you take those mirrors off, that's worth 5 horsepower at 200.
I love it. I love it.
It used to have a front bumper that was aluminum going across. When I took that off, it was 8 miles an hour, 8 horsepower at 200.
Wow.
Right.
So you start, the windshield wipers come off, and it's actually the CD on it is pretty good. The old box will comes in at about a 3.3, on the CD. And the interesting thing was the air dam in the front, the spoiler. I dropped it 1 inch and it ruined the whole car.
Yeah, exactly.
Okay,
It's funny.
so you think always dropping the front spoiler makes things better? Killed this car. So I threw that part out on the way home. Kept this one. But fun deal.
Well, no, great stuff. And what we just learned, obviously, Morel Products, your company, and we just talked to John Callies, and he talked about lifters, and now we're going to kind of dive a little deeper into a couple of things. Hydraulic roller. This is,
This is the proof in the pudding right here. He just said he's got
198 miles an hour.
right 19,000 miles. And is that a hydraulic or a solid in there, John?
Solid.
That's what I thought. 1,000 horsepower, solid, 19,000 street miles.
Yes, sir. Yeah.
So it's a myth, right? It's a myth that you have to run a hydraulic lifter to be streetable.
Right. And this car, I adjust the valves maybe once a year. That's it. So it's a very stable system. The thing people want to brag about is I have a hydraulic and I don't have to adjust it. But I find this same group may put a 710 thousandths lift camshaft in. And a hydraulic, even our top line, will not recover fast enough
Right.
like a solid. So this is a short lash cam in this thing. It runs at 6 thousandths on the intake and 7 thousandths on the exhaust.
Okay.
And so, if you think about what you're doing and what you want to do and not work on it all the time, solid lifter can be great. Now, where we sell a lot of hydraulics, where people want stuff for the street, but they're maybe 360 thousandths cam lift.
Okay.
That's all doable, get what you want.
Because the dynamics
Yeah.
aren't so great.
Aren't so great.
Because a hydraulic lifter has bleed. It's going to bleed. It does all the time. So when you've got that really rapid cam opening, it's a lot of force. It's going to be pushing the oil out. So it's going to lose valve lift. So you're going to always make more power with a solid than you do a hydraulic unless you got something way messed up.
And just to show you, let's say we take a LS1, LS3, and I have hydraulics in it, and I want to run 6,900 RPM. I take that solid out and put a solid in it. I can go 7,500 and make power.
With the same camshaft.
Yeah, same. So, like I say, there's a place for everything. You just have to understand, what are you trying to do?
Right.
And that's what we talk about all the time. Like, make your first call, not your last call. Like,
right.
What are you trying to do with this combination? And that kind of dictates what parts you need.
Sure. And I mean, on the engine in here has an aluminum block, aluminum heads, aluminum intake. And another thing that I did is years ago at Pontiac, I did special head gaskets. So this car, the water flow over the top of the chamber is uniform. And when I'll leave the line at the mile, I'll leave at 160. Now you're wide open throttle all the way for the mile.
Right.
And at the end, I'm at 164.
Wow.
So what you do on everything is kind of important.
Yeah, they're all interrelated.
Oh, absolutely. So both sides, we probably produce as many mechanicals as we do hydraulics.
Okay.
But they're just for different markets.
Right, different opportunities.
Right.
So with this engine, you said it's a solid, but which one of your solids is it?
Yeah, this has the Black Mambas.
Okay, so it's a bush lifter too.
Right.
Yeah.
Right.
Which for aluminum block, that's an important deal.
Well, I mean, I was looking for durability. Spring loads are not terrible, but this has around 675 open pressure.
Okay.
So I didn't want to have
so not
mess
nothing.
with it.
Yeah,
and so it just runs, just keeps on going.
Right.
Yeah.
Which that bushed Black Mamba lifter is what we're running in the Engine Performance Expo build.
Right.
Same thing. Which in that case, right, we've got an iron block, not an aluminum block, but you're always concerned about oil flow and having enough oil pressure. So one nice thing about the Dart block is it's got priority main oiling. So that's a great feature about that. But by not having to have a hydraulic lifter, which is now more leaks on the top end, we don't need to have a high volume, high pressure pump in this engine because we've got bushed solid lifters. So we got plenty of oil from just a standard volume pump, which as the ring guy, I don't want more oil flying around. I want to be able to have the least amount of oil ring tension I need. If I've got all these leaks, I've got all this oil flying around the motor, well now I got to have more oil ring tension to try to control that oil. That's just giving up power. I don't want to give up power. I want to make all the power I can. I mean, after today, I feel like this tall compared to John and everybody, right? And I'm like, okay, yeah, everyone's making 2,000 horsepower. We're trying to build 1,000. We're lame.
Not quite. But hey,
we'll
it's
see.
about what? Right place, right time, right amount?
Exactly. You've been listening, man.
I do. I listen all the time. I
appreciate
learn
it.
stuff.
So, John, tell us a little bit about this project. 'Cause this is an interesting little piece.
Well, a lot of people start their projects and then they go so long that they lose interest and go.
Right.
This car with the detail on it, this was an 8-year build, about 9,200 hours.
Just 9
So
That's all.
yeah.
that's what it takes at the quality level of what I wanted on the car. And it just goes on and had to put up with Mama saying, when are you going to come home and eat? That's just what happens. But anyway, I'm really happy with how it turned out, and that it still runs good. And
It's got a stereo in it, too.
Yeah.
Of course it does.
Yeah.
Right. So it's not like it's just ratted out.
Right. No, everything this guy brings into the Engine Performance Expo is a showstopper.
Yeah.
And this one also happens to go almost 200 miles an hour.
So have you noticed that there's like a Pontiac theme we've got going on here?
I'm sure.
There's this undertone, like everying comes back to Pontiac around this place.
Yeah, I wonder why. Like,
I don't know.
Like,
It's
the
on
stuff
maybe-
that's in the back warehouse that was just left around from the experience. Like when I worked at a radio station, I have a bunch of pens and stuff that I have.
Yeah.
And John's got Big Chief cylinder head sitting around.
I guess so.
What are you gonna do?
Well, the cool thing is, you go to a shop. He's got, he's got some great cars and all these cool tools. But on the walls, there's all these great pictures. Earnhardt in the 2-car when he won the championship. Prudhomme. It's this endless history. The IndyCar stuff. I mean, it's well, really cool thing is And it's in the video we just showed. I won't call it wallpaper, but you're going up to his office, going up the steps is all blueprints.
Yeah.
What motor was that? The blueprint of?
Super Duty 4. Yeah.
Incredible.
Yeah. So,
Yeah.
you know, fun old stuff, you know, you did. But it's just, it's like all the folks here, John, who's Mr. Experiment. You know,
Right.
And that's what I went through for, you know, the last 40 years. You know,
Right.
That's what you do. And you learn from things not working more than you do from things that do work.
Listened to a podcast yesterday, and they were saying that exact same thing. Is that it was Edison, right? It's like, yeah, I didn't fail. I just learned a million ways things didn't work.
Right. You know,
Yeah.
from your failures, you grow, and
Yeah,
that's
always.
it. You fail forward.
Yep,
Right. You go,
always,
okay. That's
always.
you got to build that. But I like the fact that John is still out there doing stuff and having fun.
Yep.
Like this guy is a barrel of fun. He's got always got a
exactly.
fast car, cool thing. You know, like life is to be lived, right? What's better than 198 mile per hour street
Standing
rod?
mile, exactly.
Standing mile street rod. My goodness.
Well, you know, you gotta have a fun little day. I was going to church last week. Took this car to go to church, and we ran. A guy in a new Corvette came up next to us. I turned the nitrous on, and we had a little go on the street. And he couldn't believe that I pulled him. He was pretty upset. So yeah, that's fun.
I love it. There you go.
Little did he know.
Talk about your Sunday drive.
Exactly. Well, we're going to hear more from John. John, thank you very much, and Lake. And now we're going to keep it on going here at the Engine Performance Expo. Very happy to be here at Straub. And Chris Straub going to talk a little bit about not just parts and pieces, but some of the opportunities in the engine performance industry.
What a day, what a day, what a day. Yeah, my brain is swollen. I've learned so much today.
They told us, don't start cars. We are not going to listen.